Alright, hey guys, welcome back to the digital nightmare that is the state of Massachusetts. And boy, is it a dark, dreary, dismal day out there. But you know what, I love these kinds of days. You know, these are the kinds of days where you just want to stay inside, read a book, maybe curl up with a loved one if you are so fortunate. And it's also a great day to just stay at home and code, which is what we're going to do today. In my last video, I promised you guys that I would be going over the programs and scripts in Black Hat Python, and I am here to fulfill that promise. So let's just go ahead and dive right in. We're going to be creating a Netcat clone, as seen in the book Black Hat Python by Justin Seitz, and Tim Arnold. And if you don't know what Netcat is, it's basically a networking command line utility tool that uses TCP and UDP protocols to establish connections between separate hosts. A lot of the time, if you do CTFs or any kind of penetration testing and you get remote code execution on a machine, one thing you might do is open up or run Netcat on that on the attack machine, and then get a listener going and get a reverse shell to connect back to your machine, which is has a listener running on it, a Netcat listener. Anyway, I can show you better than I can tell you. So we're just gonna run Netcat, put in my IP, and then the port, listen, command shell. So I run that, and now we have a listener going. So then back on my host machine, right, I'm just gonna say same thing here, except I'm gonna put in the IP of the other machine, the same port, and that's it. And I should get a connection back. Hit Control D. Now I can hit LS, and you can see we can enumerate the directory, the home directory. You can say something like uname, and see that it is a Linux box. So from here we could start, like, you know, traversing directories, looking for information, usernames, passwords, whatever, as we try to get privilege escalation. So this is what we're going to be making today, you guys. We're going to be cloning Netcat. So this should be fun. So let's go ahead and do that. Let's just jump right in. So let's just get rid of all this, and we're just going to start fresh. All right. So I have some ASCII arts down here. Just threw that in there. Just threw that in there for fun. You know what I mean? Thought it was a nice touch. Let's start by importing our libraries. So we're going to need argparse, and I'll explain what these libraries are as we come across them. Shellx, socket, import subprocess, sys. I think we're going to need threading, and we are going to need text wrap. I think those are all the libraries we're going to need. So the first thing we're going to do is we're going to go ahead and create this execute command, and this is going to be one of the command line arguments. And this is going to be a command line argument that basically says, hey, execute this command I am providing as an argument. And we're going to say cmd equals cmd.strip, just to get rid of any trailing white space the user might put in there. If not cmd, return nothing. And if there is, we're going to store it in this variable called output. And we're just going to say subprocess check output. They recommend you use run, but this is what they use in the code, so we're going to do it that way. Shellx.split cmd standard error equals subprocess standard output. And then last but not least, return the output and decode it, since that information is traveling, is being sent as bytes, so it needs to be decoded. So, like, really quick, if you're curious about what this subprocess library is, let me just break it down for you. It's basically a library that allows you to spawn processes. So you can, like, literally start programs on another machine. Let me give you an example. I'm going to create this thing. I'm going to say subprocess, and I'm going to say check output, and I'm going to say, I don't know, ls. So now, if I run this, it should execute that command. And it does, but you see, the output is in bytes. So that's why we have to use decode, to decode that from bytes to plain text. But check this out. If you use run which is what they recommend, and I don't know why they didn't use it in the book. This is what you get. So now you see it actually like listed out. It's cleaner. There's no escape characters, and it even returns a status code of 0, which means there were no errors. So that's why they say you should use run when you use the subprocess library. For some reason, the authors use check output in the book. Don't know why. Now, another thing is this. So we have the shellx library, and the reason that is if you try to execute like multiple commands, like if you want a long list and also see hidden directories, well, let me just long list because I don't want to do that. Notice this. We're going to get an error. You cannot pass multiple command line arguments, which is where shellx comes in. So if I use shellx and I say shellx lsa or ls-l, this should work now. Oh, hold on. What did I do wrong? Shellx. Shellx. It's never closed. And you see now we get the long listing. We were able to provide multiple command line arguments. And that is because, shellx basically separates these commands into what they call tokens and stores them in an array. As you can see, our args are ls and l-l. So that's what shellx kind of does. That's why that's there. Don't be confused by any of this, you guys. We're going to get through it. So next we're going to say if name is equal to main, and then we're going to use this argparse library, right? So we're going to say argparse dot argument parser. And what this argparse library is, it's basically a way of creating command line tools, basically, where you can get help information, examples, all that stuff. So if you like use command line tools, I'm sure you've seen stuff like this, right? Like let's do ping-help, right? So like you use command line tools and you're not familiar with it and you want to know how to use it, you use this H option, which usually like outputs this like really helpful information on how to use that utility. And that's what argparse is going to help us do. It's going to help us write our own command line utility tool with this kind of help information, which is great. It's really awesome. And if you've ever wondered how those tools are written, this is how that goes down. So it's a great learning opportunity. So first thing we're going to say is prog, which is the program name. And we're just going to say BHP net tool. And this actually isn't in the book, but it is in the documentation. I added this to put my own flavor on it. You don't have to, but that's what that is. So it's basically the program name. And then we have description. And we're just going to say, you know, a Netcat clone from Blackcat Python. And then we're going to do formatter class. And this is just to clean up the output, basically, and get good indentation and stuff like that. And we're going to say argparse.raw description help formatter. And then we're going to say epilogue. And this is going to be like the example, the usage examples. And we're going to say textwrap.dent example. And then we're going to provide some examples for the user. So let's go ahead and do that. So let's say, you know, here's an example. One way you could run it, you could say, you know, target, whatever, port, whatever, listen, command. So here's one thing they can do, right? Another thing they can do is they can execute. You know, they can provide an execute argument, and they could say something like cat etsy password file to see usernames on that machine, right? So execute command. They can also do something like upload a file. So mytest.txt, upload a file. And then they could echo text to the server. They could say, you know, echo whatever, target. text to server. And last but not least, just a regular old-fashioned connection. So these are going to be like all the examples that this program is going to output to the user. That are usage examples, which is really helpful information when using command line tools. So now we need to actually create these arguments, and we're going to do that by saying parser.add argument, and the first argument will say C, and then they can long list it. Action equals store true. This action equals store true just means it's a Boolean value, which means like there's no arguments provided. That's all that means. Like this doesn't take any arguments. Some help information, we'll just say command shell. Okay, next we'll do argument dash E for execute, and we'll say help equals execute command. That's all that is. Another argument we want is maybe listen, long list it. This is also a parameter that takes no argument. So we'll also say store true. That's all that means. Help equals listen. Okay, then we'll do parser.add argument, and we'll add the upload argument maybe, or the port. How about just do port? And this one is a little different. Port, and then we gotta say type equals integer, because that's what it is. Help equals specified IP. Parser.add argument, upload. Long list again, so they can do it both ways. God damn, mofo. Help equals specified, or no, upload. I'm tripping. Upload. Let's do upload file. And then parser.add argument, T for target. Help equals specified IP. Now we have all these arguments. We're going to say our args equal parser.parse args. And that's basically like this args variable is all those things we just wrote out. Right? So at this point, we should be able to get some help information. I should be able to say netcat-h. Look at that. That is so cool, right? So like that's how we make these cool command line tools. And if you've ever wondered how it's done, in Python anyway, this is one way you can make your own command line utility tool and output this helpful usage information with the H flag. So there's that. Moving on. So let's go ahead and get back here. Let's do if args.listen. So if it's a listener, we're going to have an empty buffer. And the buffer is where the data is being sent. And if there is data, we're going to say system standard input dot read. Right? And then let's create a netcat object. So we'll say nc equals netcat. It takes args and it takes a buffer. Got to encode it. And then we're going to say nc.run, and we're going to create this run method when we create our netcat object. Boom. So far, so good. So let's come here and let's actually create this netcat class. Let's initialize it. Self args buffer equals none for now. Let's create some attributes. The args, the buffer, a socket. Now a socket is just an IP attached to a port. That's it. So an IP address and a port, like 21 or 80 or 8080 or whatever. So it's going to be socket.socket, socket.af init. Don't be confused by this. All that AF init means is use IPv4 addressing. That is it. That's all that means. And then we're going to say socket.sockstream. What does that mean? That just means use a TCP protocol. Okay, so then we're going to do self.socket.setSockOpt. Well, once again, we're going to say socket. Yeah, that word is really repetitive when building these sockets, but hey, it is what it is. And And we're going to say sol socket. No, yep, sol socket, I believe. Yeah, that's correct. And then socket again. This time we're going to say reuse adder1, which basically allows you to like reuse this, like the same host can try to connect multiple times, like take connections from that machine. So boom. Now we're going to create the run method, which we ran down below already, if you remember. Did it down here. See it? So we're going to say if self.args.listen, if they have a listen command, run the listen method. That's it. Else run the send method. Neither of which have been written by us yet, but they will. I hope you're following and keeping up with this, and I hope I'm not moving too fast. So now let's create the send method. So we're going to say self.socket.connect, and this is going to connect to the listener. Self.args.target, it's a tuple, and it takes two parameters, target and port, which is the socket. And then we're going to say if self.buffer, if there's a buffer, send it. Self.socket.send self.buffer. That's it. Now we're going to create this try except block, and we're going to say while true. So this is going to keep it going. We're going to say receive length equals 1, and response is going to equal an empty string. Now, while we are receiving data, just run. So while there is information in receive length, keep running. We're going to say data equals self.socket.receive. Yep, brain fart. And we're going to take chunks of 4096 bytes. Then we're going to append this. We're going to say receive length equals length of data. And then response, the actual response is going to contain this. And we're just going to say data.decode. So we're going to store whatever data was sent inside of response. Okay? Now, if receive length ever gets under 4096, we're going to break out of this loop, which means we're no longer getting anything. So we can break out, right? If there's data in the response variable, print it out to the user so they can see it. Print the response, and then give them the ability to send another command. So that buffer is going to equal input. Give them a new line, and then send it, and the cycle continues. And we have to encode it, of course, because it's being sent as bytes. Now, in the accept block, we're going to say accept exception as keyboard interrupt. Print user terminated. And then do self.socket.close and sys.exit. That's it. That's all there is to this send method. Alright? Hope that makes sense. Now we're going to do the listen method. So we're going to say listen, self, if self.args, oh no, you want to just bind, self.socket.bind, self.args.target like we did up there, self.args.port. And this is for the listener. .socket.listen, and it can have up to 5 connections in its queue. And then while true, we're going to say our client. We're going to create a client socket. It's going to handle all these connections. Equals self.socket.accept, and a thread. Client thread equals threading. Thread. Target equals self.handle. We're going to create this handle method. Args equal client socket. And then run it. Start. So that's the listener. Now, last but not least, we get to handle all this. And it takes 2 parameters, self and client socket. And we're going to say if self.args.execute, so if they provide the execute command method that we created earlier, we're going to store all that in output. And we're going to say execute, we're going to call that function right here, and we're going to execute whatever command they sent or provided. And then we're simply going to send it back. Self client socket.send output, and it has to be encoded. elif self.args are upload. If they're uploading a file, we need a file buffer in bytes, right? And then we're going to say while true, data equals client socket dot receive, and once again 4096. If there's data, append it to the file buffer. Plus equals client socket equals data. I'm sorry, we already have that. There we go. Boom. If not, just break out of the loop. All right. Now we need to write that data to the file. So with open self.args.upload and write it in bytes as f.write self.args. No, I'm tripping because we have that in the file buffer. Write it to the file buffer. Boom. Right? And then we'll send them a message saying we did this successfully. So save file as self.args.upload. And then send it. Client socket.send message.encode. Gotta always encode it. That's that. So last but not least, elif self.args.command. If they are sending a command with an argument, cmd buffer equals, well, this is without an argument actually. Cmd buffer equals empty byte string, and then while true, try, and they're gonna send this client socket.send in bytes. This is gonna be like their command prompt that they're gonna receive, pretty much, right? And while there's no new line in that buffer, we're gonna say cmd buffer plus equals client socket.receive, but only 64 bytes this time, right? Because like if it's a command, it shouldn't be like a whole lot of data. It should only be a few characters. Response equals execute whatever's in that cmd buffer. Cmd execute it. Cmd buffer dot decode. Right? And then if there's a response, let's send it. Client socket dot send cmd buffer dot encode. It's being sent, right? And then let's give them an empty buffer to start over. And once again, it's just an empty byte string. And then last but not least, our exception. Accept exception as e print f server killed by however they killed it. That's it. Close our socket, exit the program, and voila. Literally, that's it, guys. We built a Netcat clone. I mean, what was that? 25, 30 minutes? Should have worked just fine. Let's say if we can do Netcat. Got H, that works. Oh, made a mistake right there. I forgot the not keyword. While new line not in cmd buffer. Works fine. Could we get a listener? Let's see. Dash port 5. And it runs. So it's trying to connect to something right now, as I demonstrated at the beginning of the video. So yeah, that works great. And that's all there was to that, you guys. You know what I mean? Not very difficult. you know, if you really just take the time to understand this code. There's so much documentation for Python. You have tools like Chat2, which can help you decipher a lot of this more cryptic looking stuff. But don't be confused by any of this. Don't be scared of any of this, you guys. You know, just take your time, do your research, and you will come to understand every bit of this, as I did. So thanks for sticking around. And also, I'm aware of the fact that I don't have a great microphone at the moment, and that can be a turnoff. And if you decide to leave, I totally get that. But for those of you who stuck around, thank you for bearing with me, and I hope it was worth your time. Until next time, later.